A 508 kilogram roller coaster car is moving with the speed of 19.3 meters per second at the very end of the Shockwave roller coaster track. A hydraulic braking system applies a 11,200 Newton force at the loading dock to slow the car to a speed of 2.6 meters per second. Over what horizontal distance in meters is the force applied? In this situation, you use the equation initial kinetic energy plus the initial potential energy plus the work being done equals final kinetic energy plus the final potential energy. In this case, there is no initial height, so the potential energy will equal 0. Both final and initial potential energy will equal 0, so the equation will equal initial kinetic energy plus the work being done will equal final kinetic energy. We'll replace this equation with a more specific equation, replacing the kinetic energy with 1/2 mass times velocity squared. This is for both initial and final kinetic energy. And we'll replace the work being done with the equation force times distance times cosine of theta. In this situation, all mass, initial velocity, final velocity, and the force and the angle theta is given. The force, you use the applied force, which is the net force, because the force of gravity and the normal force is equal to each other and cancels out. So the net force is the applied force, which is 11,200 newtons. And theta, the angle, is 180 degrees because the roller coaster is moving in a horizontal distance. So the angle is 180 degrees. So you will replace the theta with 180 degrees. Now you can solve for the distance by plugging in the given information into the equation. Just check that your calculator is in degrees mode and make sure to square both initial velocity and the final velocity. And that's how you get the answer.